So the first speaker comes to us from Stuttgart. So he is a very well-known DevOps evangelist, a SharePoint guru, official Microsoft MVP, and as he defines himself, clean code addict. Please welcome on stage Mr. Michael Kaufmann.
Thank you very much. The stage is yours. Dzień dobry. I really tried that hard, so I want a response. We try it again. Dzień dobry. Ah, okay, so I really had to practice long for this. So, welcome. My voice is a little bit damaged today, but I will give my best. Let's talk about DevOps. So, DevOps is not a tool you can buy or install, and it's not a method you follow with these are the meetings. DevOps is a new way of approaching product and your customers. So, there's no one size fits all, and you have to find your way. And this is what we're going to talk about in the next 55 minutes. So I will first explain you what DevOps is, how you can find out where you stand in the journey to DevOps, because it's a journey where you go on to and it normally never ends. And then we will go step by step through your application lifecycle and look at the obstacles you find and how you can overcome them. So like find the bottlenecks, fix them, and I give you a tool that you can use, but I'm not here to sell you Azure DevOps. So I don't get money from Microsoft. I'm here to sell you DevOps because I just believe in it. And I think this is the new way, and it makes engineers happy, and it makes customers happy. So as I already was introduced, I give this short. Michael Kaufmann from Germany. I'm an MVP for Azure DevOps, now since 2015, and I'm an ALM consultant for many more years. So, okay, let's start with what is DevOps. To explain what DevOps is, you always have to go back and look how we worked many years ago. Most of you already know it or can remember it. It was like waterfall approach. The waterfall approach is very natural. If you go to a project manager and you say like, okay, build this thing for me, and it's a complex thing, it's always like, okay, let's do this, and then this, and this. So this is a very natural approach, and it's not bad. And it's still the way we work or we build software today. It's we design it, we get the requirements, we make an architecture, we build it, and we ship it. It's still the same. So it's only natural to just make this into phases and say, okay, we have first a phase, A, then we have this milestone, then B and C. So the problem with this approach was it took like 12 to 14 months to ship a reasonable product. Then we shipped it, normally burned on a CD, to the customer, and it took a few months to roll it out. So the problem was, or the bottleneck, time to market. If you came out with your product and your competitor came with a super new cool feature 2 months after, it took you 1 year to compete with this and to change your product in this direction. The other problem was the quality. We all remember like Windows Vista or Millennium. So what happened when the quality went down? We made the testing phase longer, but it did not help. For every bug that was fixed came a new bug. And the third obstacle was delivering value. So you only could find out if you're building the right thing at the end of the delivery, so when the product was at the customers. So that's why we started this sport called ALM, Application Lifecycle Management. What is like the overall management of your entire application, from the idea it is born, over development to production. So it's a really big thing, and it's too big, actually. So what it contains is like requirements engineering, design, architecture, planning and management, build and release, and monitoring. So the whole thing, that was really big. But the bottlenecks we had were time to market, delivering the right thing, and quality. So the focus in these years was on the left side, agile development. So what all the companies, the big companies and the tech companies started to do were working agile in sprints. So this had the big advantage. We were faster because we had these 2 weeks or 3 week sprints. The quality went up because what most companies did was they get rid of the role of the tester. So they took the testers and the developers in one team, and they were just called engineers. So look, what they did not do, they did not fire all the testers and said, okay, we only have developers. No, no, no. It's cross-functional teams with developers and testers. And the quality went up. It was also now much better to see if we are building the right thing, because every 2 weeks you could deploy to a test system and you could get real user feedback and you could see if the feature works or does not work. So the bottlenecks were fixed. So there was the next problem. It was that the devs were now pretty fast, and the ops guys that had to operate the application, they were like, wait, tranquilo, we have to slow down, I want stability. And the devs were, yeah, but we can deliver every 2 weeks, so we have the pressure from the business. We have to get this out faster. And that's why there was a new set of bottlenecks. It was the release management. How do we get this fast to production? A new increased demand for infrastructure. As the devs go faster, they needed more machines, more scalability, and more infrastructure, and the operation teams could not stay up with it. And there was missing insights in production. So if you now had shipped everything, and in production, this can be a really complete world there. So you test something on a test device, and it's awesome, and you install it in production with a lot of users, and the performance goes down, and so the users are not happy. So what was missing still is insights and monitoring. So this is like the right side here of ALM. How do we get now our fast-delivered increments to production? So, and what they did, or what we did in our industry, was like more or less the same move like we did with the testers. We shipped, or we get rid of the role operations and moved it into the cross-functional teams. And what is the drive behind all this? The drive was a book from Daniel Pink. Anyone knows the book? Yeah, okay, a few. If you don't, and you don't read, I also added the link to a Tech Talk video you can watch on YouTube. It's 20 minutes. It's really worth looking at it. So what Daniel says that how we treat or how we manage our companies is the wrong way to motivate people. So the surprising truth about motivating people. And so the basic is this candlelight experiment. So experiment is you have 2 groups. You have a box of thumbtacks, of matches, and a candle. And you say, okay, you have to adjust the candle to the wall as fast as possible. So then you give the one group a reward and the other one not. So the trick, the solution is you have to put out the thumbtacks of the box and use the box to adjust the candle to the wall. So this is why it's called outside the box thinking. And the interesting thing is that if you do this, the group that gets rewarded is slower. So this is like crazy. We all expect someone, if you give someone a reward, it gets faster, it gets better. And it's not the case. And they tried it, even if the reward is higher, the performance is lower. And they tried this in America and India, all over the world with this experiment. So this is interesting. So how do you motivate people in our industry? How do you motivate creative people? Not by bonus, not by money. You motivate them by giving them autonomy, mastery, and purpose. Autonomy, the desire to be self-directed, the mastery to become really good in what you do, and the purpose, something meaningful, to do something meaningful. And I have a few examples that you understand this, because I think this is the key of DevOps. So this is what it's all built upon. So you all know the company Atlassian? Yeah, they build Jira. They have like one day in the week where every engineer can work on whatever he wants. So there's no plan, there's no direction, there's just one day, work whatever you want. You have to deliver something. That's why it's called FedEx Day. So you had to deliver the next day. I think today it's more than one day, so they call it Ship Day, but it's still the same thing. And the results were awesome. So a lot of the good ideas there came from this day. A lot of bugs that were forever in the system were fixed. And Google does the same thing. At Google, like I think 20% of the time, the engineers can work on whatever they want. And a lot of the great products from Google come from this time. So like Gmail and a lot of products. So sometimes the best things arise if you're not push them. Another good example is this. Anyone remembers the Microsoft Encarta? It was a digital encyclopedia from 1993, I think, until 2009. When it was discontinued because the other thing went over, it was Wikipedia. So in the 90s, or in 2001, when Wikipedia was created, who would have thought that the biggest company then, Microsoft, with a lot of money and thousands of people, has this product, and another one creates a free product without money, without a company, it's just a foundation, and who won the game? Wikipedia. And why? There are people that work 8 hours, they don't like their job, and at night they sit there and they write for free articles on Wikipedia. So this is the motivation is here. They have a purpose. It's something good. They want to be part of it. And this really drives people. And this brings me to open source. Open source, it's the same thing. I think there are now like 33 million developers on GitHub, like 100 million repos and a lot of things. So this is, most of them, not all, now a lot get paid, but at the beginning they were all like in their spare time. So they also had this 8-hour job, they hated, they made software they did not like, and at the evening they worked for free on big projects worldwide. So this is like the biggest self-organizing team worldwide today, development. And then if you look now at Microsoft, they are now the biggest open source company in the world. And when you remember a few years back when Linux came and Munich started to install Linux on their desktops, how Microsoft was against Linux and against open source. And look how they changed. So since 2012, it was growing and growing and growing in every year. And now Microsoft has thousands of developers. They pay to work on open source software. Yeah? They are on GitHub. They do their stand-ups in YouTube or on Twitch, and they engage with the community, and they are only paid to work on open source software. So I want to show you a small video. This video was presented on the keynote of one of the divisions of Microsoft when they started their agile journey. And I think this pretty much explains what DevOps is about.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
67 seconds. Feels a lot longer, eh? So now let's see how this is in 2013. So and that's a little bit, for me, the key of DevOps. You don't have to give the people always something good or to change the world or something. A purpose can also be to be the best. So these engineers here in this team, they might take orders, they might get yelled at, but they have this common purpose. They want to win the next championship. They want to be the best. And they don't accept the state of the art. So you don't win races if you just follow the things the others do. If you look, oh, they changed the tires like this, oh, we do it the same. You won't win. You always have to try out something new. You say, okay, we want to be the best, let's get on. So we are like 67 seconds, we're going to get it down. How can we optimize it? Let's try something new and then do it. If it works, good. If it does not work, we try something else. So a lot of companies, if I talk to them, are like, oh, well, I can't give them a purpose. Our purpose is to earn money. And of course, that's good. Other companies have this purpose. But try to be the best. This is also a purpose you can give your developers. And let your developers be the best in what they do in this area. This motivates them. And then you don't have to give them orders. You can just say, okay, build a product the customer loves and get out of the way. So the definition of DevOps from my front and Brown is, DevOps is the union of people, processes, and products to enable continuous delivery of value to our end users. So I'm more the visual type, so I made a big picture. And you see, in the center are the people. And the people on two sides. So you have the engineers, and it's all about the people. It's not about resources that you shift, that you plan. You have a multi-functional team. They work together to build a product. Now the other peoples on the other side, the customers love. And to deliver this value, there must be a demand. If there's no demand, you build the wrong thing. So if you look at this picture from the other side, from the customer side, it's like user experience. You feel like the customer, you want to find out the demand, it's user experience. If you look from the engineering side, it's DevOps. You deliver the value. How can we deliver this value fast? And if you go a little bit back and you look at the Agile Manifesto, it's more or less the first paradigm of the Agile Manifesto. Our highest priority is to satisfy the customer through early and continuous delivery of value. So DevOps for me is like Agile 2.0, like Agile on steroids. So where do we stand? So in 2017, there's this State of DevOps report from Puppet and Dora. You can download it. In 2017, you see that in Europe, we had like 27% only that participated in the study, and like 54% in the United States. So in 2018, this changed a little bit. Europe goes up, but we are still far behind. And I added this because we are here in Poland, and you see Poland is even more behind. So Germany is a little bit up, but if you compare it with America, we are far behind. So especially we in Germany, I don't know how it's here, but we are really late in cloud adoption. And cloud adoption and DevOps, they are really like, they go hand in hand. If you do DevOps, you want to do cloud because you are faster, you are better, it's easier for you to win and to be the best. And if you have cloud, you need DevOps practices because of the changing environment. You cannot just install something, it will run for a year. The cloud is changing always, and you need DevOps practices to keep up with. So cloud and DevOps are like this. And if you look worldwide at the platforms, you see Europe is way behind. America went or run in front. Asia is now pretty good with Alibaba, and they have really huge platforms. But Europe, 3%, Africa, 2%. So I think this is really what we have to change the next years. We have to come up with a pace here and get close to America or Asia. So, how do you approach this? I don't know where you are in your DevOps journey. I said it's a journey. It has no end. It's not where I say, okay, we do DevOps because we have this and this practices. It will always go on, and you always find a better solution. So, there's this theory of constraints that says a system like a pipe would be infinite if it would not have a constraint. So, what means that in your system, a system that flows, that has flow in it, always the biggest constraint defines the velocity. Yeah? Because you see on the left side, if you have more coming in and you have this bottleneck, then you have like a traffic jam. And if you open it up or you slow down, then you get no traffic jam, but you have this underutilized capacity. So what you have to find in your pipeline or in your flow of value are the bottlenecks. So there are 2 free assessments you can take. It's one from DORA, one from Microsoft. And you fill it out, and it's like a questionnaire, and you get a fancy graph here that says you where, in which practices you are behind and where you are up in your pace. So this is pretty good. I encourage you to do it. Or you can buy someone and get a custom assessment, someone that comes to you, look at you, and you get a more detailed report and better advices what you can change. So, but this is a good way to find out where you are. So, now we'll go through the entire life cycle. We start with the culture, which is the hardest thing to spot and the hardest thing to change, so we start with it. Then we go over work items, code, build, release, one round, and look at what you can do, how to spot your bottlenecks, and what you can do to overcome the bottlenecks. Culture. So what you have to look for in your company is a growth mindset, like not a fixed mindset where this was always like this, and we always did it like this, and we cannot change, and he's only an engineer, or things like that. For a growth mindset that is willing to change. And look for values and principles. How does people behave? Do you always hear excuses like, this is not our fault, this is the other's fault, and this is their fault, and it's management? Or the fixed mindset like, this was always like this. We cannot write here unit tests, they won't allow us. Or no ownership, so, oh, the others are responsible for this. You don't have to do this, leave this, but I can fix it. No, it's the other responsibility. Yeah. Or also a decoupled management, when everyone is talking about they above and they down. These are all indicators that you have a cultural problem. So, but what do you do if this problem is there? So, a lot of people think, we cannot change it, this has to be changed by management, but they have the same problem. How do you as a manager change the culture? Yeah? You can write PowerPoints and say, these are our values, but it's just a PowerPoint. It does not mean the people will do it. So you have to change. And it's the management and you, of course, but if the management does not, you can start in your team. You can just start by doing the right things. And I have this overview, old view, new view, old world, new world. So in the old world, we were focused on planning, and now we focus on delivering. In the old world, we compete and did not collaborate. So we had this department, they wanted to be better with that department. And now we collaborate. We have like this open source in the companies, and we work together, and we help each other to bring the company forward. We have fluid teams instead of static hierarchies. Individual productivity was then, today is collaborative value generation. Yeah. Back then, it was efficiency of processes, and now we have effectiveness of outcomes, yeah, and so on and so forth. So you can look for these things, and then look for this. The problem is everyone wants change. Everyone wants that the things are better, but no one wants to change. So you have to change, your team has to change. And then probably other teams will follow. So my advice is do the right things. It's better to ask for forgiveness than for permission. So just start doing the right things. Trust your team. And if you really have a culture problem and you can get help, get help. Get an advisory that looks at you, and this can help to bridge the gap to management if you have. But anyway, start with doing the right things. So if you don't write unit tests yet, just start them. Start by, if you don't have a pipeline, build one. Use all your autonomy level to do the right things, and then if it's better, measure it and talk about it. Tell the other departments, look what we did. It's much better like this. And this will create growth and will change the culture in your company. So work. If you are in a classic company, then it's pretty probable that work is one of your bottlenecks. Because if your company is plan-driven, you always are asked for estimates. So give me this estimate. And if you give a detailed estimate, you have a deadline where you have to adhere, and then you have to go faster, and the quality goes down, and you get in this circle. So work is, in a lot of cases, the bottleneck. So, anyone knows this company here? It's Toyota. And they created in 1947 a system called Kanban. And they changed the model of their factory from a push or a planning model to a pull model. So they're not planned ahead what resources were required where. They went to a pull model, so I have this station, I need this, and they had these cards that are now typical or known for Kanban that traveled along with the things to visualize it. So Kanban is just a way of visualizing work and going to a pull model instead of a push model. So this is visualized it, so you have like the machines, they have output, but the demand of the next machine triggers the delivery of the first one. So you have this pull model here. And if you compare this to a Kanban board and to the software development, so you have like your Kanban is a board, you have your cards on it, it has like analyze, build, test, deploy. And you don't push their cards in and say, okay, you have to deliver that. So the next station or the next part in the process, they pick whatever they want, what they can do, and you limit work, so you only work on maybe 2 or 3 things at a time, or ideally 1, and then the next will come. So you work from the demand to the delivery. So what's the problem here? The problem is delivering value in small units. So I have an example. How do you build an elephant in small increments? Yeah? The theory is like this. But in reality, it's more like this, and then that, and then that, and then that. So this is not how you do it. If you want to deliver increments with value, you start with a small elephant, and you get bigger and bigger and bigger. Or even better visualization is this. If you want to build a minimal viable product, you have to deliver value from the beginning. So it's better, it's not we build a car like a wheel, another wheel. We start with a skateboard, then a roller, a scooter, then a bike, and so on and so on. So this is the challenge, to find small increments that have a real business value. So if you're in a company that is really plan-driven, what can you do? You have to get your autonomy level to go to this model. And you can do this by influencing the estimations. So if someone comes to you and asks for an estimation, so what I see is most developers go back in their team, they make a work breakdown, they make the small elements, and then they say, how long do you need? 2 hours. How long do you need? 4 hours. And you add up all the hours, and you have an estimate you give to the customers. Did this ever work? Not in my company. So what you have to do, you always have the abstraction layer. And you can use like analogy estimations. So you have this big module that your internal customer wants. And you say, okay, given the fixed team I work with for the last half year, if I have this team with a chance of 80%, I can deliver this in X month. So you don't say 100%, you're never 100% sure. And you said, okay, we need this team. If you change the team, I cannot tell. We need a fixed team, and we have a something percentage chance to deliver in this time. And you can look at other projects you did. You said, okay, we have a project, it was more or less the same. We delivered in 3 months. We had a bigger one, a smaller one, and you can use this. This is the better estimate. Then take the requirements, break it down, make a backlog, and use Kanban or sprints to work agile on this product or module. So my tip for work is find your autonomy level, move your team from the push to the pull model. Don't make waterfall sprints, even if you do Scrum. I see a lot of teams that do like this 2-week or 3-week waterfall where they plan all the tasks in hours. Go to a pull model and focus on the throughput, yeah, and not the planning and deadlines. And limit work to only work that your team works on one thing. So what I wanted to show you here is, if you not yet have a Kanban board, you can use Azure DevOps. It has a really rich Kanban board. You can customize it. You can add columns. You can add swim lanes. So this is really easy to customize. Let's add a swim lane, for example. So, of course, you don't have to take an electric version. You can also take a wall and pin paper to it. But in my experience, the developers love more the digital way. And this Kanban board, what I wanted to show you, also has a live sync, so you can use it in different rooms or in remote teams. And if, for example, with my mobile, I now change the state. Yep, you should see it going over. No, I think it was too long idle. Whoop. Okay, I'll leave it, doesn't matter. So, yeah, but it's really nice. So we have a big meeting room with a wall and a beamer, and if you have a remote team, they have like the Surface Hub with a camera, and you stand around it. And if one team moves the card, the other team sees the card moving. So you have this live sync. But if you have a PowerPoint presentation for half an hour, it sometimes does not work, especially in Edge. But I want to make this quick, not spend too much time on it. This is just, you can use it. This is there, the board. You can, I show you the pricing later. You can install it, you can use it. And even if your company has other systems around it, like you have a charm process and you have to write documents in your team, you can easily use Kanban here to optimize the flow of your work. So code. Code normally is not the the bottleneck. Some companies still don't write unit tests, for example, so then yes, it is. You should start with it. Or if you don't use a version control or still on subversion, I advise you to use Git. Git, in my opinion, is the source control that won the game. And it's because of the way to collaborate. So if your company or in your team, you still have like, this is your code, this is mine code, and everyone works on their same piece of code, and at the end of the sprint, you get it all together, then it's a bottleneck. And then I advise you to go to Git and with pull requests. Who uses Git? A lot. Okay, that's good. Who uses pull requests? Like 50%? I'm not sure. Okay, so I really advise you to do this. And I also wanted to show you a live project from us. So this is a project where you see all the pull requests here that are completed in the last time. You see the number of reviewers, and you see a lot of comments there. So I picked out one, for example. Live updates are temporarily disabled. So what you see here is the pull request. You see that there are 2 reviewers have approved. You see the build passed with all the tests. You see the SonarQube integration. And you will see a comment down there, the linked work items and the reviewers. And if I go down, you see here the discussion. It's in German, I'm sorry. But you see the people with smileys and emoticons, they really work together on this code. So the team really gets a feeling for this is our code. This is not mine on your code, this is our code. And the integration here is really great. For example, here you see, I set up the SonarQube integration. So every time the SonarQube detects an error, it gets injected here in the pull request as a comment. And I have some developers that responds to this and say, oh yes, boss, okay, I will fix it. That is pretty funny. But I think this is really the new way to work together. So if you see this and you say, wow, this is completely different what we do, then coding might be a bottleneck for you. So my advice, use Git if you already do. Look for a backend, even GitHub or Azure repos, or it doesn't matter. Look for a good pull request experience that matches in your environment. Write code with a good quality. It means TDD, write unit test. Use feature flags to not use long-lived branches. Make short branches, make pull requests, merge them in, and get them early out. So, build, test, and deploy. I have this together like pipelines. And in my opinion, right now, Azure Pipelines is the best pipeline solution in the market. You cannot use it just with Azure DevOps. You can also use it with GitHub, for example. And it has a really great experience, especially if you're an Azure developer. So what you can do, so this was a year ago or a little bit longer, this was always my super demo. I set here up from code, a sample project, how to create the pipeline, how to deploy it to Azure. And today, everyone can do it. It's not hard. So what you just have to do, go to the Azure portal and create a DevOps project. And then you ask here what language you want to use. Is it .NET, Node.js, PHP, Java, Ruby, you name it. Yeah? Then you click Next. Then you can have some options like, okay, do you want ASP Core, ASP.NET, IoT, do you want a database or not? Yeah? And then you select where you want to deploy it to. So let's take Kubernetes. Kubernetes is fancy. Yeah? And next. And now you can fill in and you can create a new Azure DevOps project. You can take an existing one. And what it will create is a sample project with an entire pipeline from code, build, release, including tests. Not all projects have tests, but a lot have tests. And the sample projects are on GitHub. So if you like them, you can contribute, and if you find something that is not perfect and you want to add tests, you can do it. So I created this for you. And this is what it looks like if you created it. So you have in the Azure portal, like this Azure DevOps project, where you have from code over the build to the pipeline and all the Azure resources in one place. So if you can click now here on the code, and it directly jumps into Azure DevOps, and you can see the code. You see the state of the build, which release was deployed, and you see here the cluster that it is running. So this, for example, is the sample application, and you can see the pipeline and the test, and the build and the release, and everything runs. And this is now the application, the sample application that runs in Kubernetes. So this is not perfect, and this is not for production use. But if you want to, for example, start with Kubernetes on Azure, or if you want to do web apps with .NET Core, and please start with this. Create a project, create the pipeline, look at it, how you do it, and then start learning Kubernetes and doing it right. Because a lot of people, they start first with like .NET Core and Kubernetes, then they have it local running, Docker start, Docker run, and then they try to build the pipeline after that. And it's much harder. Start with the pipeline, start with the entire loop, like you need your development loop, your inner loop, how you get it up, how you test it, and you need the pipeline, how you ship it. If you start only with the inner loop and you have your application ready and then want the pipeline, it's much harder to get it right. So my advice, go to the Azure portal, create a DevOps project, and look at the pipeline. Just look how it is done. Yeah. You also find always infrastructure as code here. So all the Kubernetes cluster is already as an ARM template in the repo. You can use it to work from. Important for the pipeline is everything must be automated. Every manual step is a bottleneck. You have to remove it. And if you start with it, then you can go over to more advanced techniques like blue-green deployments, zero downtime deployments, or ring-based deployments. So, if you have problems in operations, then you're pretty far in your DevOps journey. So the chances that you're already there are small, but they might be there. So if you really have your pipeline up and running and you can deliver continuously, then you will start to need more insights what your users does, so that you can start to experiment. And it's important to have the right tools and to build the traceability in your application. So this can only be done if ops and devs work together. What do we need for data? Because it's really fast that you have too much data or too less data. So even if you have a front end and back end, they have to work together to have the correct data that you can really know what the user is doing. Because the front end normally don't map one-on-one to back end calls to the REST API. So I don't have a demo here, but my advice here is, first of all, take responsibility. As a development team, you build it, you run it. It's not like, even if your organization is not structured like this and you have like still an operations team that acts like a guard, take responsibility, act like if you own it and fix it, and it's your responsibility as a development team. Even if you need help from the ops teams, it does not matter, but take responsibility, run your application, and build it with failure in mind. In a cloud world, everything can fail. The back-end things, and even if you're not in the cloud will come, and then you will have this environment where something can fail. So build your application with failure in mind. Build like circuit breakers in their checks, think that there can be connectivity issues, and then use a rich logging system where you really can data out. If you already have this, then you can go over to more advanced techniques like practice the failure. It's called chaos engineering or the Simian army, like Netflix does it. So once in a while, they turn a production service off and see how it's going and if everything works or not. So, and in production, it's not a test system, it's not a simulation. They really turn randomly services down and look how the system responds. Because the system must be built that it still keeps running. It gets a little bit slower, some functionality does not work, but the entire system must be running. And these are really hard exercises, but these are really the more advanced techniques. The same thing with security. If you want to go to, if you are in this space and you want to go to security, you always also do like this red team, blue team practices and things like that. So for monitoring, you can use application insights. It's not a built-in Azure DevOps product, but it's an Azure product and it's free until a lot of telemetry. And if you do Azure DevOps with Azure, this is really a good integration. This is a good starting point. So I talked now a lot about the Azure DevOps and how you can use it to fill your gaps or your bottlenecks. And I also wanted to say how much it costs. For open source, it's free. And even if you have open source on GitHub, you can use the pipeline, for example, with GitHub, and it's still free. And it's free to 10 parallel jobs, and so this is really enough for an open source project. So if you have open source projects on GitHub, use the pipeline system. For small teams, it's also free. So the bottleneck here might be the pipelines. You only have one pipeline with limited minutes. So if you're really a DevOps team, you will need to buy more pipelines. But to get started, this is enough. So 5 people free. And you have the stakeholder license. The stakeholder license is free also. So if you're like a 5-man team and you can invite everybody in your company to look at your work items, to create bugs and to work with you, but not really on the team, not with code, not with pipelines. And if you grow, it starts with $6 per user. And the 5 are still free. So if you like 10 people, you pay like $30 a month. So I think this is a reasonable offer. Of course, if you do a lot of pipeline, it will get a little bit more expensive. So, let's recap. I told you what DevOps is, how you can find out where you stand, the assessments, and how you have to approach it. So always look for your biggest bottleneck. Yeah? There's no reason to fix things if you have another bottleneck. If operations is still the bottleneck, you have to work there. And you find the bottlenecks and fix it. And I just gave a very quick overview over the Azure DevOps verticals now, like repos and boards and so on. And you can pull them out on and off in your project if you only need one. So if you only need boards, you can go in there and say, I only want boards, and the navigation goes down, and you can only use boards with your Jenkins system that you're using. Or if you're already on GitHub or GitLab or something, and you want to use the pipelines, you can do the same thing. Just use the pipelines, install them, and use them with your existing toolchain. So it really integrates good. So here's one more thing. This is the definition of done of the Azure DevOps team. So they don't have a definition of done like all the unit tests must be passed and the acceptance test and we need code coverage. No, they say it's live in production and it's collecting telemetry to support or diminish the starting hypothesis. And I really loved this when I saw this the first time. This is really advanced DevOps. They say, okay, we have this team, they built this experiment, they collect the data to prove that what they deliver has value or not. And the This is just to motivate you where you can come if you follow the DevOps path. Yeah? So it's not just testing, throwing something in, it's really measuring the value of the features that you deliver to your end users, so that you can build a product that the users love and not just, like and use it because they must. The users must love your product, then you will love to build the product. And this is what DevOps is about. So I encourage you to start doing it, to start focusing it, to embrace the cloud and DevOps practices, and find your boundaries in your companies and push if you can't, and there's something in the way. Because most of the time we are so caught up in the daily fights and fixing bugs in production and running around that we don't have time for the important things. I think this is important. We have to change the culture, and so I'm basically done.
Thank you very much, Michael. We have a small gift for you as a thank you for being here with us, a small token of our appreciation. Thank you very much.
Ladies first.
Ladies first.
Thank you very much.
Thank you very much. A round of applause, please.